Welcome back to Further Solutions Academy. On this video, I'll be walking you on. I have some problem which was sent to me through one of my friends, all the way somewhere, and I have to provide solution, so that other people can see it. Still on problem. Let me call the topic problem on matrix. Please, or matrix, wherever it is, plural and singular. Let's take note of that. That is the topic. And the problem says that determine the value of k if any we give a what? Number one, unique solution. Number two, no solution. Number three, infinitely many. Now, many solutions to the system. Look at the solution. These are the system of the what? Linear combination. These are the linear combination. I think we have done that earlier. Linear combination. And we need to generate k. That is what we are trying to. There are two questions. I think this will be number one. The second one will be solved earlier. I mean later by the end of the video. Now, how do I solve this problem? Let's try to solve it and work it out, and let's see how it will be. Okay, I have this problem and I want to solve it. The first thing I will do is that I need to generate my augment, augment matrix, augmented matrix. Now, I've explained augmented matrix earlier that you have your what? Normally, before the augment, you can see that what? The matrix, the vector equals to what? This is going to be, I think I'm talking about one coefficient of the given coordinate. We use coordinates or we use variable. Anyone you feel like, no problem. I have 1, I have k, and I have 2. Okay, let me not confuse you guys. 3, 4, 2, and 2, 3, minus 1. This is going to be the matrix. Now, the vector y, x, z. And the b is what? 2, k, and 1. Now, this is how to position any given matrix on this, using matrix problem method to solve any given problem. And I've told you that we have different methods of solving this type of problem. We have talked about row reduction. We have talked about Gaussian elimination method. We have talked about row transformation. We have talked about inversion method, and so on. And there are many of them, even grammars and so on, as many you can use. Even you can use your normal linear combination. You make this, let this to be this. Now, I now want to generate my augment. Now, my augment matrix is going to be what? 1, 1, 2, 3, 4, 2, 2, 3, minus 1. This is my augment, which I will have 2, k, and 1. Now, I will run towards my what? Gaussian elimination method, which is with the help of Gaussian elimination method, it will be easier for me to handle. Don't forget that there are difference between Gaussian elimination method and echelon form. Now, Gaussian elimination method, you are just trying to, which I've explained that in our video before now, you are turning this part, you are turning to 0, which it will generate a triangular matrix, which we have done that, and you will be working upon your what? Principal diagonal. Now, Now, I want to turn this value to 0. The first thing I will do, I will have my R2 equals to R2 minus 3R1. My R3 will be equals to R3 minus 2R1. Now, by so doing that, I will generate what I need to generate, which I will have 1, k, and I have 2. This will be 3, k. This is going to be 3, and this one will be 6. Now, 3, I have 3 minus 3, it will be 0. 4 minus 3, it will be 1. 2 minus 3k, I will have 2 minus 3k. Don't mind my handwriting. And this time around, I'm having k minus 6, I will have k minus 6. Okay. Now, the next thing I'm having now, please clean this to avoid silly mistake. Now, 2 of that, which is I have 2k, and 4. This minus this, it will be 0. This minus this, it will be 3 minus 2, it will be 1. Yes, am I lying? Yeah, I think 1. This minus this, it will be minus 1 minus 2k, and this minus this, it will be minus 1, my augment. Now, can you see the first 2 is what? Is 0. The next thing I need to get now, this must be 0, which is this number must be 0. Now, what should I do? I will now say that what? This particular matrix and that matrix will be equals to. Okay, I think I just discovered a mistake now, which is this. I was minusing with 2 instead of 4, which is going to be minus 3. Thank you for correcting us. Now, the next thing, I want to reduce this to 0. It means I'm talking about R3 will be equals to R3 minus R2. You can't use R1 again, which we have done that earlier. By now you understand that. Because of that, I will be having 1k, 2, 1, 3k, and k minus 6. And this time around, I will have 0. This is going to be 0, sorry. And this will be 0. This will be 0. 1 minus 1. This time around, I'm talking about minus 2 minus 2k minus 2 plus 3k, which I will be having minus 3 plus k. Now, it means I'm talking about minus 3 plus k, and also I'm having minus 3 minus bracket, or which is minus k plus 6, which it will be 3 plus 3 minus k. 3 plus minus k, yes, that's how it will be. 3. Now, I have 3 minus k. Now, can you see I have my leading rule? This is a leading. Now, the next thing now is now to go to the condition given to us. The first one said that unique solution. Now, if you are having unique solution, this is 1, which is our leading rule. Now, this one, if it has unique solution, it means you are basically on this particular position. Now, it means I will say that what? Minus 3, that is number 1. Now, unique solution, it means minus 3 plus k is not equals to what? Is 0. It means we are talking about what? Unique solution. Now, if it is not equals to 0, it means I will say that what? My k is not equals to what? 3. My k is not equals to 3. Now, for us to have unique solution, it means here must not be equals to 3. K must not be equals to 3. If k equals to 3, you know that it will make this rule to be what? 0, 0, 0. And you know the implication of linear combination, linear dependent and linearly independent. You know all those things earlier. Now, it means for us to have unique solution, it means it must not be equals to what? 3. Take note of that. Now, the other one, no solution. If it has no solution, it means number 2. Take note of that. It has no solution. It means minus 3 plus k, it will be equals to 0. Now, you will notice that, okay, I think there is light now. Okay, now, you will notice that my k will be equals to what? 3. Now, put k 3 here, you will notice that there won't be any solution. It means it will be linearly dependent. I think we have done that earlier. Linearly independent and linearly dependent. Now, the third condition, which is the third one. Now, the infinitely many solutions to the system. Infinitely many solutions to the system. How do I do to that one? Now, the next thing you need to understand that is that for us to get it well, sorry, this one, it will be infinitely many solution. It means it will be linearly dependent, which is my k will be equals to 3. This one will be for condition 3. Now, for no solution, it means that set of solution, it will be what? It will be zero. It will be zero. Do you get me right? That is what we talked about. I think by now you should understand that. Now let's try to show another problem that will really help us to understand this part very well. Okay, see another problem that a friend also sent to me. I told you earlier that I will be talking about two problems. Now, look at the problem. Let me read out the question. Consider the following system of equation for some constant k1 and k2. Now, what differentiates this with the first one is there is k1 and there is k2. This is the system of linear combination. Determine the value of k1 and k2 since that the system has unique solution. 2, infinitely many solution. B, determine, if k1 equals to 4 and k2 equals to 1, find the solution using Gaussian method. Now, you all know this one is very simple. It's very, very simple. Gaussian method is just like the point of, don't worry, we'll see by the end of the video. Let's see what Gaussian method is talking about. Now, let me first by now you know how to set up this thing, you know how to generate your augment matrix. Now, let me run to augment matrix, straight, augmented matrix. Now, will be equals to the coefficient of a given variable, which is I'll be having 1, 2, and 4. I have 3, I have -1 and 1 and 0, and this one will be 1, k1 and k2. This is not k3, k2. Now, this is my augment. Now, listen, k1 and k2 are not the same thing. K1 and K2 are not the same thing. Okay, K1 and K2. Okay, now, sorry, I need to take water. Now, the next thing we need to do is that we need to think of a way that I think we are going on reduction, and this must turn to 0. That is Gaussian. Now, since we have that, it means I'll be talking about my row 2 will be equals to row 2 minus 3 row 1. My row 3 will be equals to row 3 minus row 1. Now, by so doing that, okay, yes, I think by so doing that, it will be fine by having, okay, I think I might having a real question. So let me quickly check the question, if it's correct or not. Okay. Now. Okay. -1. Okay. Okay, now it's correct. Now, since I have that, I'll be having 1, 2, and 4. I'll be having, this one will be, I have 3. This one will be 3, 3, 3, 3, 3, 3. That will be 6, 3, 3, 6, and 12. Yes, that's what we are going to be having there. It means I'll be having this and that. It will be that and that. It will be 4. It will be -4. Here will be 0, -4, and -5, and minus 12. Yes. Now, the next one will be, I have 1, 1, 1, 1, everything 1, which I will be having, that will be 0, is 0, and I have 1 minus to be 0, and also I have k minus 2, and also I have k 2 minus 4. Now, that is what we are going to be having now. Okay, the next thing I have to get in mind, okay, that is what is now reduced, to, this is the Gaussian method. Now, I will now turn this to what? For the solution to have, now, number 1, as a unique solution. Now, 1, unique solution. Unique solution. It means it will be what? My K1, this is K1, minus K minus 2 will not be equals to 0. And my K2 minus 4 will not also be equals to 0. Now it means my K1, it will be not equals to 2, and K2 not equals to 4. That is very, very correct. It means for that, my K1 will not be equals to 2, my K will not be equals to 4. Now, the next thing is infinitely many solution. Now, many solution means, which is number 2, number figure 2, I have infinitely many solution. Now, it means if it is infinitely many solutions, it means it will be what? My K1 equals to what? 2. My K2 will be equals to what? 4. Now, can you put those things there? You have 0, 0 on the row. It means it's infinitely many solutions. Now, the next thing, which is number B asks us to number B, which you are asked if K1 equals to 4 and K2 equals to 1. It means come here, you have to use your Cramer's rule to determine your Gaussian elimination method. My Gaussian elimination method, just like you are doing it this way, it's already reduced already. You don't need to stress yourself. 2 and 4, and 0, minus 4, minus 5, minus 12, and 0, 0. My K1 is 2. It means I'll be having, my K1 is 2. I'll be having, okay, that my K1 is 2, which is going to be what? But my K1 is 4. 4 minus 2. And my K2 is what? Is 2. It means it will be 1. My K1 is 1. It will be 1 minus 4. Now, which I will be having 1, 1, 2, 4. Let me use augment. 0 is 0. 0 minus 4 minus 5 minus 12. 0 is 0. That is going to be 2 and minus 3. Now, don't forget that we have done a reduction. Now, this time around, what we just need to do, I can turn everything a leading row to be equal to 1, or we have what? X, is it S3? S3 equals to 2S3 equals to minus. It means my S3 will be equals to what? Minus 3 all over 2. Now, my S3 equals to minus 3 all over 2. I'll move on to the next one. I'm using Gaussian elimination method now. Now, it means minus 4x2 minus 5x3 equals to minus 12. Now, what is my S3? This is my S3. Minus 4s2 minus 5 bracket of minus 3 all over 5 equals to minus 12. I think I'll be having 15. I'll be having minus 8s2 plus 15 equals to 24, which is minus. This and this, minus 24 and which is going to be what? Minus 24 minus 15, which I will be having drop 5, that'll be 1, that'll be 25, 25, that'll be 10, that'll be 29. Yes, that'll be 20, I mean 39. That'll be 39. Now I'll be having 8x2 equals to minus 39. It means divide both sides by 8 by 8. You are not going to believe it. This is higher institution work. You should know that by now. Now I'll be having 8 all over what? All over. Is there anything we can reduce there? Okay. Okay, now you can leave it like that. It means my S2 equals to what? Minus 39 all over what? 8. Now I can now go for my what? S3 by saying that what? X1 plus X2 plus 2x3 equals to what? 4. Now by so doing that, just put the value down. You put them down, which I have my x1 plus, okay, is it minus 39 all over 8 minus 6 all over 2 equals to what? 4. Now by so doing that, multiply everything by 8. I'll be having 8 x1 minus 39 minus, it's going to be 4 times 6, that will be 24. 4 times that will be 24 equals to what? 8 times 4, that will be 32. Now by so doing this, you will have your this thing 39 and 24, which will be 3, that will be 40, that will be 40, I mean 63. Now I will be having 63, sorry, permit me to manage the board. 8x1 equals to 32 plus 63, which I will be having 8x1 equals to what? This plus this, that will be 95 divided by 8, which is my s1 equals to what? 95 divided by 8. Now, all what I'm doing now, it means I can say my s3 equals to what? 95 divided by 8. That is, now I've generated my s1, s2, s3 by the given, function. I mean the given from here. That is what we need to do. That is all for. Okay, you can see. Sorry, I made a mistake. This should be x1. I have to overlook it and I have to look over again. Can you see? You can come to our channel and learn any topic of your choice: mathematics, physics, chemistry, and by God's grace, you'll be fine with it. Okay. Now, if you have any problem, you can email us. You even send message to our contact. This is our contact number on 080-344-95990. Within Nigeria, you can use this, but outside Nigeria, just put +234, and it will be very. Once again, thanks for watching.